today we'll be discussing about the classification of stellar spectra and determination of distance of stars. So basically in this experiment we'll be using a software called CLIA or video, and using that software we will be finding the spectra of different stars, and hence we also get the apparent magnitude of a respective star. And using the apparent magnitude and by the information we collect from the spectra of a particular star, we can classify that to a particular spectral type, which we'll be getting to know soon. And based on their spectral type we can get the information on absolute magnitude, and by the information of absolute magnitude and apparent magnitude we can, using this formula, we can substitute those values to find out the distance of the star. Click on the software video, and the softwares are just same, that is CLIA and video are one and the same, so the procedure is also same, no worries. Log in using your name or roll number, anything, it's fine. Click on run exercise, classification of star spectra. As you can see, as soon as this window pops up, here you can see that no telescope access. First you should get access to a telescope. Click on this telescope, click on optical, and for this particular experiment 0.4 meter telescope is more than enough, and you don't have access to this, so don't bother about it, just click on this. Yeah, got the access of the telescope. Click on OK. Now the dome of the telescope is open, so open the dome, and as soon as the dome opens, the telescope control panel is off. You should turn it on. Okay, as soon as you turn on the telescope control panel, click on tracking, and now go to a star which is nearby, and usually go to a star which is really bright enough so that you can get good absorption lines, and your spectral lines will also be really nice and clear. Okay, or else you will take a lot of time collecting the data using a spectrometer. So as soon as the box is near the star, click on the telescope, and now place these slits between the star properly. Okay, so yeah, now it's enough. Click on axis. Here you have the spectrometer. This will collect all the data necessary from the star. So ensure that photon count should be above 40,000 and signal to noise ratio should be above 50. Okay, and just don't click stop as soon as they reach the limits what I said right now. Give some time like 10 or 12 seconds, and so that you have all the necessary information collected really well. And in this particular spectrometer, or in this particular window, you should note down two things, that is the object name and the apparent magnitude, so that you can write them here. Okay, you can just write down the name of the last three digits, it's fine, and the name you can write down the entire name also, that doesn't matter. So what matters is apparent magnitude. Okay, here they have given V, but what we have considered the apparent magnitude as is small m. Okay, so write down the apparent magnitude value here, and here I have taken different stars, so I'm having different values, so never mind. So these are the necessary informations which you have to note down for this particular star in the particular table, in the particular column. Okay, so just click on go. Okay, so you can just click stop now, and you can save the spectrum. You can save it anyhow, it doesn't matter. So now after everything is done, ensure that you have saved the spectrum, ensure that you have written the object name and apparent magnitude, and close the window. Okay, so once you are done with this, go to the window, observatory main control panel, click on tools and spectral classification. Basically what we'll be doing in the spectral classification is we'll be comparing our spectral class or the spectrum what we collected from a particular star with the main sequence star. Okay, so main sequence star is like a general structure or general characteristic graph kind of thing, which helps us to understand to what particular group does this particular star or the star which we have selected belong to. Okay, and how we'll be doing it is by finding out the difference between the spectral or absorption lines between the main sequence star and the particular star what we have taken. So click on file and unknown spectra. So the spectral what we had taken now is this, so click on open. Here we got the spectra of the star what we wanted, and to select the main sequence star spectra, click on file, atlas of standard spectra, click on main sequence. Here we have another window which is quite different from these two. So what happens is you need to find out the difference, right? So click on file, display, and show the difference. Here we can see the difference between these two spectra. Okay, and you can just click on this, and you have to find out the difference till or you almost get a straight line. Okay, you should almost get a straight red line. So keep on searching. You can just, I think this is almost a straight line, so I don't think so. Yeah, this is almost a straight line. And after this, here note down this spectral type here. Okay, just next to the object name what you have taken, note down the spectral type of it, and using the appendix given to you, this is the appendix, sorry, not this, using the appendix given to you for a particular spectral type K, write down the distinguishing features here. I mean, these are the distinguishing features which you have to mention it here, and the prominent absorption lines and the wavelength. Okay, so these two are the prominent absorption line for this particular spectra. Click on this, you will get a wavelength here, wavelength number here, and the intensity over here. Okay, I have written the element name, it doesn't matter, just at least write the wavelength. Okay, don't forget to write the wavelength here. And as you can see here, the appendix, they have given CH and CN bands are developing. These two are the bands which you see here. Okay, so that's what I have written here, and note down this value as well, write them here. And based on the spectra what we have taken is the spectral type is K, right? So for the K0, or this is K5, okay, this is K5, the absolute magnitude is 7.3. okay, so this is 7.3, and the apparent magnitude earlier what we had taken is should be written here, and using the formula given to us, that is log of d equals to m minus capital M plus 5 by 5, find out the distance, and that is the find out the value of d, and repeat the same process for 3 stars and in another 2 stars, and you will be done with your experiment. This is all about this particular experiment. That's it.